Hello students, in the 11th chemistry, the next chapter we are going to discuss today is unit number 4 and the topic of the lesson is hydrogen. Okay, dear students, it's very simplest and easiest lesson. Let us discuss about this lesson. Okay, so this lesson is reduced and this reduced syllabus is published by the government, and based on the reduced syllabus I have prepared this video. Please make use of it and try to learn well. Okay, first we are going to see about the introductory part about hydrogen. So what is the need of learning about hydrogen? First one, hydrogen is a very simple atom. We know that its atomic number is 1 and it is being the first element in the periodic table. So that info we know about hydrogen. It's again given here. Hydrogen is a simplest atom. It is the simplest atom. And about the inner structure, it's given here. It contains 1 proton and 1 electron. We know the atomic numbers and mass numbers of hydrogen. The atomic number of hydrogen is 1, and so the mass number is also 1. And it contains 1 proton and 1 electron. Okay. And there is a speciality associated with this hydrogen. What it is means it's valence electron. We know about valence electron. What is valence electron? The electron present in the outermost shell of an atom is called as valence electron. And in this case of hydrogen, the valence electron is present in the inner sphere of nucleus. ஏன் பார்த்தீங்கன்னா இப்போ பாருங்க, ஹைட்ரஜன்ல nucleus will be there, then only one shell is there, in that one electron is present, so it's very closer to nuclei. That's why it's given the valence electron is directly in the sphere of nucleus. Okay, and the hydrogen is present in many compounds. There are certain compounds are exemplified here. Those are water molecule. What's the formula of water? H2O. Then carbohydrate C12H22O11, and also in proteins, cholesterol, and so on. So many of the compounds contain hydrogen in their formula. And it is a diatomic molecule. What is its formula? H2 is the formula of hydrogen. It composed of 2 atoms, and so it is called as diatomic molecule. And it is highly reactive species, being small in size, and also with 1 incomplete valence electron, it will be highly reactive. And its abundance means its availability in the earth crust. Its availability is very, very small in the earth crust. So with this, the introductory part is over. Hydrogen is being the smallest atom, or also we can say it is the simplest atom. It contains 1 proton and 1 electron. Then the valence electron is directly in the sphere of nucleus. It is present in many compounds such as water molecule, carbohydrate, and proteins. It is a diatomic molecule. It's a highly reactive species, and its abundance is very, very small. The next thing we are going to discuss is the position of hydrogen in the periodic table. Dear students, among the scientists there was a little confusion about the placement of hydrogen, where to place the hydrogen, since it has some similarities with alkali metals and also some similarities with halogens. That is why there was a confusion arises in which group it has to be placed. Okay, now in this slide we can discuss about the position of hydrogen in the periodic table, where it is placed, either with the alkali metals or with the halogens. Dear students, these are the aspects in which the hydrogen resembles with the alkali metals. I think you know about the electronic configuration of hydrogen. Can you please remember the electronic configuration? It has only 1 electron, so that its electronic configuration will be 1s1. All the alkali metals, even if you take lithium, sodium, potassium, their outer electronic configuration will be ns1. Here n will be the period number, so generally they have the outer electronic configuration ns1. So hydrogen also has 1s1, so it is resembling with the alkali metals. Then second one, it can easily form a unipositive ion. So what is unipositivity means? By the loss of 1 electron, it will be converted into H+. It is possible in the case of hydrogen. Not only in the case of hydrogen, all the alkali metals. Even if you take lithium, it is ready to form Li plus ion. If you take sodium, it will be ready to form Na plus ion, and so on. Okay, so it forms unipositive ion, same as that of the other alkali metals. Also, hydrogen is able to form halides, oxides, peroxide, and sulfides similar to the other alkali metals. And also it is a very good reducing agents. All the metals will be reducing agents. In the same way, this hydrogen is also acting as a very good reducing agents. So these are the aspects in which hydrogen highly resembles with the alkali metals. So the scientists have thought that this element has to be placed along with the alkali metals, but in an alternative way, it has some resemblance with the halogens also. Okay, my dear students, we know about the ionization energy of halogens. Generally, halogens will possess higher ionization energy. So, in the same way, this hydrogen is also possess higher ionization energy. ஏன்னா இருக்கிறதே ஒரே ஒரு எலக்ட்ரான், அந்த எலக்ட்ரானை ஈஸியாக அது லாஸ் பண்ணாது. ஸோ எலக்ட்ரானை லாஸ் பண்ணுறதுக்கு we have to supply a large quantity of energy so that it possesses higher ionization energy, and this possessing higher ionization energy is resembling with the property of halogens. Halogens also will possess higher ionization energy. Okay, and also it has the tendency to form hydride ion. Hydride ion ஒண்ணுமே இல்ல, when hydrogen accepts an electron, it will be converted into a negatively charged one, and this is called as hydride ion. It is similar with the halogens. All the halogens are in need of electron. If you give an electron to chlorine, it can easily accept and it will form a chloride ion. So like chlorine, this hydrogen is also ready to accept an electron and form a hydride ion. So in these two aspects, hydrogen resembles with the halogens. Okay, mama? Okay, that is given here. Hydrogen has similarities with alkali metals and halogens. In the properties ellame, it has a similarity with alkali metals, whereas in these two aspects, this hydrogen resembling with the halogens. Okay, so there was a confusion whether we can place this hydrogen along with alkali metals or with halogens. Okay, then finally the scientists themselves have came to a conclusion. The conclusion is given here. In most of the compounds, if you see or if you analyze many compounds, the oxidation state of hydrogen is +1. It is existing in the +1 oxidation state, and +1 oxidation state is the property of alkali metals. Only alkali metals will possess the +1 oxidation state. So they have came to a conclusion that the hydrogen has to be placed along with alkali metals. Okay, so in most of the compounds, hydrogen has +1 oxidation state, so it is placed along with alkali metals. Okay, Vama, do you have any doubt with the position of hydrogen in the periodic table? I think there will be no doubt. Okay. Okay, dear students, the next thing we are going to discuss is isotopes of hydrogen. I think you know about isotope. What is called as isotope? Isotopes are the atoms of the element with same atomic number but different mass number. Atomic number same irukum, but mass numbers will be different. Hydrogen has 3 isotopes. Those are protium, deuterium and tritium. So these 3 are the isotopes of hydrogen. What are they? Protium, deuterium and tritium. Okay, Vama? Okay. And their formulae are, for protium, the formula is H11. Atomic number is 1, mass number is also 1. Then for deuterium, the symbol is either we can use H or D. That is also same. Atomic number is 1 and the mass number is 2. Then in the case of tritium, its atomic number is 1 and the mass number is 3. Here also, instead of H, you can use the term T. Okay, Mama? Okay, so these are the 3 isotopes of hydrogen. What are they? Protium, deuterium and tritium. Then their abundance, their availability in the earth crust. Normally, if you trap the hydrogen gas and if you analyze the percentages of each isotope, means the major part will be contributed by protium. It's around 99.985%. The normal hydrogen contains the protium isotope. Then about 0.15% of deuterium and the tritium is present only in trace quantity, very very small quantity. What is present? Tritium is present. Okay, and now we can discuss about their inner structure. Okay, there are the pictures given about the protium, deuterium and tritium. Okay, this protium has only one proton, so in the nucleus one particle I have drawn, one electron that is revolving around the nucleus. In the case of deuterium, number of proton is 1, number of electron is also 1. So this brown color ball I have used to represent proton, and this green color I have used to represent electron. Then this orange color is neutron. Here there is one neutron, mass number is 2, atomic number is 1. So 2 minus 1, that is equal to 1. So it has one neutron. But in the case of protium, there is no neutron. If you 1 minus 1, 0. Here there is no neutron. Neutron number mass number minus atomic number. Okay, so here 2 minus 1 only one neutron is present in the nucleus. Then the next one is tritium. Tritium's atomic number is 1, so it has one proton and one electron. So brown color ball represents proton, there is one proton. Then this green color ball is electron, there is one electron. Then these orange color balls represent neutron. Here there are two neutrons. Okay, that is given in the last point. The protium has no neutron. Then deuterium has also been called as heavy hydrogen. Heavy hydrogen. And tritium is highly radioactive. So radioactivity is a property of certain elements from which there is a spontaneous emission, spontaneous release of radiation energy. And the nucleus will automatically energy release. Such kind of atoms are called as radioactive atoms. Here tritium is radioactive. So in the one words it can be asked, out of the three isotopes present in hydrogen, which is radioactive? Which is radioactive? The tritium is radioactive. Okay, so these are the properties, these are the isotopes of hydrogen. What are the isotopes of hydrogen? Protium, deuterium and tritium. Okay, dear students, next there is an important concept we are going to see, that is ortho and para hydrogen. Okay, okay, dear students, we know all the atoms, whatever the atom it is, they have a particular spin about their nucleus. The nuclei of the atoms will be spinning at all. Okay, here we are going to think about the spinning of hydrogen nuclei in a hydrogen molecule. Okay, we know about the formation of hydrogen molecule, isn't it? How does a hydrogen molecule will form? By the combination of two hydrogen atoms. Two hydrogen atoms cherumbodhu we'll be getting a hydrogen molecule. So since it has two hydrogen atoms, we can say that it has two hydrogen nuclei. Okay, and about the spinning of the nuclei, we can have two types of hydrogens. Those are ortho and para hydrogens. So about them we are going to discuss now. What is called as ortho and what is called as para hydrogens. Okay, look at this picture first, students. These two balls represent hydrogen atoms. It is one hydrogen atom and it is another hydrogen atom, and this arrow are in the same direction, which means they are spinning in the same direction. Both may be in the clockwise direction or maybe in the anti-clockwise direction. So in a hydrogen molecule, when the nuclei are spinning in a same direction, such kind of hydrogen is called as ortho hydrogen. Then para hydrogen, in the sense the spin will be in the opposite direction. One of the hydrogen nuclei will be in the clockwise direction, whereas the other one will be in the anti-clockwise direction. Okay, is it clear? What are ortho and para hydrogen? Ortho hydrogen is a hydrogen molecule in which the nuclei of both the hydrogen atoms are spinning in the same direction, either clockwise or anti-clockwise, whereas para hydrogen is a molecular hydrogen in which the nuclei of the hydrogen atoms are spinning in opposite direction. One will be in the clockwise direction and the other one will be in the anti-clockwise direction. Okay, so those are ortho and para hydrogens. When the spin of the nuclei are in the same direction, it is called as ortho hydrogen. When the spin of the nuclei are in the opposite direction, then it is called as para hydrogen. Okay, then their availability we can see now. At room temperature, about 75% of orthohydrogen and about 25% of para hydrogen is present. Okay, Mama? Okay. And if we discuss about the stability, generally ortho form of the hydrogen is more stable than the para hydrogen. Okay, Mama? Okay. And about the properties. These two things, ortho and para hydrogens, are similar in chemical properties. Their chemical properties are almost similar, but they can differ only in their physical properties. So there is a difference of physical properties is given in your textbook. I didn't take that one. You can refer your book for your further understanding. Okay, Mama? Okay. So these two forms of hydrogens, ortho and para hydrogens, they are similar in chemical properties, but differ in physical properties. Okay. Next, there is an important 5-mark question, that is conversion of para hydrogen into ortho hydrogen. How to convert para into ortho form of the hydrogen? There are 5 points given. It's very important one. Okay, ma'am. First point is in the presence of a catalyst. Or catalyst today presence la para form of hydrogen can be converted into ortho hydrogen, and those used catalysts are platinum or iron. So in the presence of such catalysts, the para form of hydrogen can be converted into the ortho form. Then second way of converting is passing an electric discharge. By passing a quantity of electric current, the para form can be converted into ortho form. Okay, Mama? Okay. Then heating the para hydrogen above 800 degrees Celsius can cause the conversion. When we heat the para form above 800 degrees Celsius, the para form will be converted into ortho form. Then the fourth method is mixing with paramagnetic substances, and the examples for paramagnetic substances are molecular oxygen, nitric oxide, and nitrogen dioxide. So when we mix the para hydrogen with these paramagnetic substances, it will be converted into an ortho hydrogen. Then finally mixing with nascent or atomic hydrogen. Okay, Mama. So what are the ways to convert para into ortho? First one, in the presence of a catalyst, that is platinum or iron. Then second one, by passing an electric discharge. Then third one, heating above 800 degrees Celsius. Then fourth one, mixing with paramagnetic substances like O2, NO, NO2. Then finally mixing with nascent or atomic hydrogen. Okay, Mama? Okay. Then finally we can see about the magnetic moment. The magnetic moment of para hydrogen will be 0. ஏன் 0ன்னு பார்த்தீங்கன்னா, இப்போ நமக்கு இப்படி ஹைட்ரஜன் நியூக்ளியை இருக்குது, அதில் ஒரு நியூக்ளியை வந்து கிளாக் வைஸ்லையும் இன்னொரு நியூக்ளியை ஆன்டி கிளாக் வைஸ்லையும் ஸ்பின் ஆகிறதுனால their net magnetic moment is cancelled, and so we can say the paramagnetic substances are said to possess 0 magnetic moment. Okay, but the magnetic moment of ortho hydrogen will be twice as that of proton. ஒரு ortho hydrogen உடைய magnetic moment வந்து நார்மலா புரோட்டானுக்கு இருக்கிற magnetic moment போல 2 மடங்கு இருக்குது. Okay, magnetic moment is nothing but பொதுவாகவே எந்த ஒரு மெட்டீரியலுமே ஸ்பின் ஆயிட்டே இருக்குது அப்படின்னா it creates certain amount of magnetic moment. Okay, so for ortho hydrogen, its magnetic moment is twice as that of proton. Okay, Mama. So this ortho and para hydrogens over. What are ortho and para hydrogens? Orthohydrogen is a hydrogen molecule in which the nuclei are spinning in the same direction, whereas parahydrogen is a hydrogen molecule in which the nuclei of the hydrogens are spinning in opposite direction. And there are different methods suggested for the conversion of para form into ortho form. Then finally, the magnetic moment also we have seen. Okay, ma'am. Now we can see about the preparation of deuterium and tritium. Okay, deuterium formula we know D12. Okay, there is only one method is given, that is electrolysis of heavy water. Water means we know H2O. In water, instead of hydrogen, if deuterium is present, it is called as heavy water. Okay, so by electrolysing D2O, we will be getting the D2 alone. In the normal water itself, there is a certain quantity of D2O is present. That is given here. Normal water contains 1.6 into 10 to the power minus 4 percentage of D2O. Normal waterல இவ்வளோ percentage எது இருக்குது? Heavy water இருக்குது. இப்போ நம்ம அப்போ தனியாக ஹெவி வாட்டர் ப்ரிப்பேர் பண்ணி அதுக்கப்புறமா எலக்ட்ரோலைஸ் பண்ணுறது கொஞ்சம் கஷ்டமான ப்ராசஸ். ஸோ இன்ஸ்டெட் ஆஃப் தட் வாட் வி வில் டூ இஸ் நார்மல் ஆர்டினரி வாட்டர் வில் பி ஹைட்ரலைஸ்ட். Normal water will be electrolyzed. So during that electrolysis, the hydrogen present in that water will be electrolyzed first. H2O full-ஆவே electrolyze ஆகும். Then remaining the water will be enriched with the molecules of D2O. Then D2O will be electrolyzed. So that equation is given here. D2O on electrolysis it forms D2 and O2. Here D2 is deuterium and O2 is oxygen. ஓகேவாமா? எப்படி டியூட்ரியம் ப்ரிப்பேர் பண்ணுறாங்க? பை த எலக்ட்ரோலிசிஸ் ஆஃப் D2O. When D2O is electrolyzed, there is a formation of D2 and O2. Okay, okay. The next one, preparation of tritium. Dear students, we know that tritium is occurs only in a trace quantity. பொதுவாகவே tritium கொஞ்சம் போல அமௌண்ட் தான் கிடைக்குது. அதனால் இதை நம்ம ப்ரிப்பேர் பண்ணுறதுக்கு தனியாக எந்த ஒரு மெத்தடுமே கிடையாது. only in the nuclear reactors it will be prepared. Okay, there is an artificial method for preparing tritium. It's given here. Only one method is there. It's very important 3-mark question. How is tritium prepared? When lithium is bombarded with neutrons, lithium neutrons வச்சு மோத வைக்கும்போது there is a formation of tritium. That is given here. Li36 plus N01. N01 means that is neutron. Okay, when lithium is bombarded with neutron, there is a formation of a helium nuclei. Along with that, tritium is obtained. T13. So this is the preparation of tritium. Okay, mama. Lithium on bombardment with neutron, there is a formation of helium nuclei and tritium isotope. Prida, this only one method is there for the preparation of tritium. Deuterium can be prepared by the electrolysis of D2O, whereas tritium can be prepared by the bombardment of lithium with neutron. Okay, va? Okay. Dear students, we have seen about the preparation of deuterium and tritium. Now we can see the chemical property of deuterium and tritium. Okay, only a limited chemical properties are there. Okay, in the case of deuterium there are 3 chemical properties, and in the case of tritium only 1 chemical property is given in your textbook. Okay, first 3 equations are the chemical properties of deuterium. Okay, first one, reaction of deuterium with oxygen. Okay, D2 plus O2 forms D2O. It is similar to that of the formation of water molecule. H2 plus O2 gives H2O. In the same way, D2 on reaction with O2, it forms D2O. Likewise, look at this another example. H2 plus Cl2 gives HCl. Isn't it? Yes. In the same way, instead of H2, D2 is reacting. D2 plus X2. Here X is the halogen. The halogen may be fluorine, chlorine, bromine or iodine. Okay. So D2 plus X2 gives 2DX. Formation of deuterohalide. Okay, mama? Okay. The next, exchange reactions. Exchange reaction is nothing but the position of one atom will be exchanged with another atom. There are 2 examples I have taken. One is methane and the one more is ammonia. What is the formula for methane? It is CH4. Okay, it is on reaction with deuterium. There is a formation of, look at this example very clearly, students. CH4 is there, no? Instead of this 4 hydrogen atoms, this deuterium can replace the position. So it will be CD4 plus 2H2. This H4 is eliminated as 2H2. Then next example, ammonia, 2NH3 plus deuterium. The place of hydrogen will be replaced by deuterium. So we'll be getting ND3. It is called as deuteromethane and it is called as deuteroammonia. So these 2 are the examples for the exchange reactions of deuterium. With oxygen we have seen, with halides we have seen, and also the exchange reactions we have seen. Then finally, the chemical property of tritium. Okay, mama. Tritium is a beta emitter. Already I told you it is a radioactive one. Radioactive na enna spontaneous அதனுடைய நியூக்ளியஸ்ல இருந்து எனர்ஜி வந்து எமிட் ஆயிட்டே இருக்கும். சரியா? ஓகே, இப்போ பாருங்க tritium formula T13, it is spontaneously emitting a beta particle. This is beta particle. Beta particle is nothing but an electron. ஒரு எலக்ட்ரான் தான் நம்ம என்ன சொல்லுவோம்னா beta particle னு சொல்லுவோம். Okay, beta particle along with the formation of helium 3 isotope. And one more important point is given, the half-life period of tritium. Its half-life period is 12.3 years. Okay, so this is the only one and only chemical property about the tritium. Okay, the next thing we are going to discuss is compounds of hydrogen. Okay, dear students, according to your entire curriculum, there are a number of compounds given, but in the reduced syllabus, only about water we are going to discuss. Okay, first we can see generally about water. Students, can we imagine a life without water today? No, it's not possible at all, because we need water to survive, isn't it? Yes. Okay, and we know that the Earth's surface, around 70% of Earth's surface is covered by seawater, but that we didn't use for domestic purpose, even though the Earth's crust is about around 70% of water. It's covered by ozone. Okay, and also our human body is made up of 65% of water. So the relation between human and water is very, very significant. Okay, you all know about the formula of water. What is the formula? H2O. Okay, the same formula I have written here. In the center, one red color ball I have drawn, no, that is oxygen. This is oxygen. It has covalently bonded with 2 hydrogen atoms. So this is the structure of water molecule, H2O. Okay, mama. Okay, and there are 2 criteria we are going to see, that is hard and soft water. Hard water na enna, soft water na enna பார்க்க போறோம். ஓகேவா? ஓகே, ஜென்ரலி எப்போ வந்து ஒரு வாட்டர் வந்து சலைனாக மாறுமா, எப்போ குடிக்க முடியாமல் போகும் அப்படின்னா நம்ம என்ன சொல்லுவோம், ரொம்ப உப்புத்தன்மையாக இருக்குது. ஸோ அந்த உப்புத்தன்மைக்கு காரணம் என்ன? வாட் இஸ் த ரீசன் பிஹின் த சலைனிட்டி ஆஃப் வாட்டர்? ஸோ இட் இஸ் டியூ டு த பிரசன்ஸ் ஆஃப் சர்டைன் சால்ட்ஸ். தண்ணியில் ஒரு குறிப்பிட்ட சால்ட்ஸ் கரைஞ்சிருக்கிறதுனால தான் அது உப்பு கரிக்குதுன்னு நம்ம சொல்கிறோம். ஓகே, அண்ட் தோஸ் சால்ட்ஸ் ஆர் either bicarbonate, calcium bicarbonate or magnesium bicarbonate, calcium chloride or magnesium chloride, then sulfate, calcium sulfate or magnesium sulfate. So இந்த மாதிரி salts எல்லாம் தண்ணியில் present ஆகி இருக்கிறதுனால தான் water becomes saline. Okay, so what is the reason for the salinity of water? It is due to the presence of bicarbonate, chloride and sulfate salts in water. Okay, okay, so the water associated with such dissolved salts is called as hard water. Hard water na enna? The water in which the salts of bicarbonate, chloride and sulfate are present. Okay, then soft water means what it will be? Yes, the water which is free from such soluble salts are called as soft water. Water free from salts of calcium and magnesium is called soft water. Purida soft water enna, hard water enna purida? Okay. Okay, ma, we have seen about hard and soft water and the reason for the hardness of water. Now, the hardness is of 2 types. One is temporary hardness and the one more is permanent hardness. இப்போ temporary hardness என்னன்னு பார்க்க போறோம், permanent hardness என்னன்னு பார்க்க போறோம். Okay, and the temporary hardness in water, it is due to the presence of HCO3 minus. HCO3 minus na bicarbonate. The bicarbonates of calcium and magnesium. சரியா? அதாவது calcium bicarbonate or magnesium bicarbonate. So these two are the salts responsible for the temporary hardness of water. What are they? Either calcium bicarbonate or magnesium bicarbonate. ஓகேவா? இப்போ எப்படி இந்த டெம்பரரி ஹார்ட்னஸை ரிமூவ் பண்ணுறது? By doing what? This temporary hardness can be removed. So there is a simplest method. If the water is associated with these kinds of salts, calcium bicarbonate and magnesium bicarbonate, we have to take that water and the water has to be boiled. Nalla boil panna veikumbodhu this bicarbonates will be converted into carbonates and the carbonates will be settled down. Nalla boil பண்ணும்போது அந்த carbonates கீழே settle ஆயிரும். So after settling down, if we filter the water, you can get the soft water. சரியா? இப்போ bicarbonate மட்டும் இருந்துச்சுன்னா no problem. We have to boil it. So while boiling, the bicarbonates will be converted into carbonates and it will be settled at the bottom. And if we filter such solution, you'll be getting the soft water. Okay, so there is an equation is given, calcium bicarbonate CaHCO3. When it is heated, this calcium bicarbonate is converted into calcium carbonate CaCO3 along with the formation of water and CO2. So this CaCO3 is insoluble in water so that it will be settled at the bottom. கீழே நமக்கு என்ன ஆகும்? Settle ஆகும். So that can be filtered. So filter பண்ணி எடுத்ததுக்கு அப்புறமா you'll be getting the soft water. Okay, so this is one of the methods of removing the temporary hardness. There is another method is there that is called by a scientist named Clark's method. Okay, so in the Clark's method, what we will do is the hard water will be treated with lime. Lime oda formula is CaOH twice. So calcium bicarbonate along with CaOH twice. At that time, this calcium bicarbonate is converted into calcium carbonate CaCO3 with water molecule. It's a precipitate. It will be settled at the bottom, so it can be easily removed by filtering. Okay, Mama? Okay, so the temporary hardness we have seen, and about its removal also we have seen. Okay, the next one, permanent hardness. Permanent hardness 9 and pakapur. Okay, va? The permanent hardness of water is due to the presence of chloride and sulfide salts of calcium and magnesium. If the water is associated with calcium sulfate, magnesium sulfate, calcium chloride and magnesium chloride, then it will be referred as permanent hardness. Adukku per enadhu? Permanent hardness nu solranga. Okay, so there are two methods suggested for the removal of permanent hardness. Those are, one is by using washing soda, whereas the another one is using ion exchange process. Okay, what is the formula for washing soda? It is sodium carbonate Na2CO3. This is the formula for sodium carbonate or washing soda. So here I have taken MCl2. M is either calcium or magnesium, metal chloride and metal sulfate. When heated with washing soda Na2CO3, it's converted into MCO3, metal carbonate. Already we have seen the metal carbonates are insoluble in water, so they will be settled down. So அதே மாதிரி இங்கேயும் வாஷிங் சோடா போட்டு ஹீட் பண்ணும்போது கீழே செட்டில் ஆகுது. ஓகேவா? ஸோ அப்போ ஃபில்டர் பண்ணி எடுக்கும்போது நமக்கு பியூர் சாஃப்ட் வாட்டர் வந்து கிடைச்சிரும். ஓகேவா? தென் another method is ion exchange process. ion exchange process அப்படின்னா இதுக்கு மேக்ஸிமம் ஜியோலைட் அப்படிங்கிற ஒரு சிந்தட்டிக் கிளே வந்து யூஸ் பண்ணுறாங்கம்மா. சரியா? அதனுடைய ஃபார்முலா பார்த்தீங்கன்னா NaO Al2O3 SiO2 H2O. சரியா? இதை ஷார்ட்டாக நம்ம வந்து